Haha. All right, let's make some cool shit. Let's go into our system network, start building this thing out. So eventually gonna look something like this. Bam. Cool. Go into our orange operator there. Select this and delete it. I know I got a nice clean network palette. Let's do object merge and bring in, click this little icon thingy and bring in the prep here. Okay, so nice and organized. Let's start with the bars. Let's get that basic setup going. Let's just start with the DOPS. Let's get this into give it some gravity and solver stuff and that stuff. So, okay. Basically, we have everything here. Groups. So let's just start with an assemble. Connect that. Create pack geometry. And we can rename the output, the prefix, to bars. Just like that. All right, we got a nice and packed prims there. All right, we need a, well, let's just throw it directly into, let's just throw a null here. Start to separate these things here. All right, let's do a dot network. Okay, I always like to keep the .NET inside of a SOP network. And, you know, I've seen people put .networks out here, and you can reference in objects. It's all up to you. It's all up to the artist. It doesn't, you know, it all has the same output anyway, but it's per preference, right? So, but I like to keep it inside the SOPs to have it nice and organized and manageable. I don't like constantly going back out to the main scene view. So all right, so now we got the DOPS. Let's start building this real quick. So we have packed. Let's do RBD packed object. Connect those two together. Let's just get this thing falling into place. Just get the gravity working and everything. So since we have it on the first input here, select our packed object, do geometry source. We want to do first context. So first, second, third, fourth, first context there. All right. And there it is, it showed up. So let's give it some gravity. All right. Let's just play this back. Well, it needs a definitely needs a solver here. So let's do bullet solver. 1, 2, 3. Let's push play. There it is. It's starting to fall. Now that's pretty slow. That's moving pretty slow. That's because the scale is, now remember this scale, let's do this real quick here. And hit spacebar 4. This is hitting around, what is it, like 80, 75, 80, 85 meters, and that's 85 meters times 3 feet roughly, so it's around 255 feet tall in world space. Now if you divide this by 10, what do you get? You get 25 feet, right? Divided by 6, that's 6 foot. That's a person. That's 4 people. So let's say 1, 2, 3, 4. So yeah, this looks like a normal sized scaffolding, but it's scaled up 10 times in world space because the scaling helps the dynamics create more accurate collisions and behaviors. So in that case, if we go to the gravity, we got a default always by -9.8. Let's multiply this by 10, and now we have matching values to the matching scale. So if we hit play again, it's falling properly. All right, let's hit tab, let's throw a ground plane and a merge. Let's move ground plane first and bullet second. That is important, and we need a static solver. Whoops. Okay, static solver in order for the ground plane to be get included. All right, this is the really basic layout, and if you hit play, works nicely, falls properly. Cool. All right, I could turn the display the ground plane off, so I don't need that. You can go up here, display on and off. Okay, cool. We have that. Now let's start to add some more properties. All right, let's go back up into the SOPs. So we have that. We've got that working solid. Gravity looks good. Collisions seem pretty fine. So it works nicely. Okay, so I'm going to start to build the constraints out. And let's see how we can get that starting to evolve. We can evolve this one by one, step by step. Little steps first. Okay, so out here, I'm going to split off into this area on the right. I'm going to create a little bit of a constraint network. Start with, we need an unpack, because in an unpack we need a connect adjacent pieces, and that will create the actual constraints. All right, let's move those over. All right, so in order to apply this, we need to unpack it. So we assembled it. It created a naming structure. So if we go down to our geometry spreadsheet, move over to primitives, select that. No, wait, on the points. Yeah, we got the names right here. So if I just connect this to the connect adjacent pieces, it doesn't do anything because it is packed, and we need to unpack it. So unpack it. And since we have the naming structure applied on the point level, since it's packed, I need to move transfer the attributes back down one level, the unpacked level, so that way it will retain the name per object. So you can see it still has the object or the name here. If I get rid of the transfer, it disappears. Very simple, very simple. All right, go back to connect adjacent pieces. Now we can start to see some stuff. Go to search radius. If I just bump this up a bit here. Let's change this to connection type 2. The middle one here, just adjacent pieces from surface points. This is more of a kind of an overall structure we're going to use for our glue. This will hold together the structure. So what we're going to end up doing, you'll see, is we're going to start to layer the constraints. So this is one constraint type, and then we're going to make another one that will be pointed to specifically the matrix pivot reposition metal bending type system. That's pretty cool. Okay, almost done. Let's throw an attribute wrangle. This is going to define our constraints. So first thing we want to do is change it to primitives, because we are applying it to the primitive level, since the connecting node creates an actual primitive. So let's do S for string at constraint underscore name equals, I'm going to name this stick. Alright, then we need a type. What is this type of constraints? I need to define that. It's called position. It's a position constraint, which is pretty default. Alright, we got that going there. So what's going on here? Oh, it needs semicolons. There we go. Cool. All right, and that's it. We can finish this up, put a null. We can name this, I like to do CON for constraint. And it's a stick. Cool. All right, we got that. Now let's just test it out. Let's go back into our dops. Move this down. Let's roll out a first constraint network. Constraint network. Pipe that in there. And this needs a constraint. It needs an actual glue. Put it into the type. All right, and we got that. Now we need to, since we named it stick, let's rename that to stick. That is, now it's pointing to the constraint, so you can see it updated there. Let's say, oh, it's red. No, okay. So obviously we need to tell this constraint network, which I'm going to rename to connet underscore stick. And we got to point it to the constraint. So I'll go to system, con stick. There it is. Okay. There we go. It's updated. So if we play this back, that's how it works. So it's very nice. It's very nice. That's cool. It's very weak too. So let's go here. Let's up the strength. Add 2 zeros. Let's turn off the, select the constraint network and go to guide options here and uncheck this. It slows the viewport down pretty significantly. So, all right, that's crumbling down. Let's save it. Let's up this to, put like a 7. What's this, 7 million? All right, we're getting somewhere. So, okay, so that's good. That works. Now, before we get into the juicy constraints, let's start to define some, let's give it some active attributes so we can control the activation and when this thing starts, is allowed to move. So it's in our SOP level. Let's go out underneath assemble. Let's go back up here. And I need to get a wrangle. So all I want to do is throw that in there. All I would like to do is tell this thing, give it an active attribute. So off the bat, let's give it a complete let's activate it fully. So you do I for integer equals active, no, not equals, at active. It's calling active. And what is it? 0 1 0 1 semicolon. Okay. So if you middle mouse click, we have an active attribute on the point, packed point. Okay, so we have that. So for example, if I hit this to 0, I go back into dops. If I hit play, it shouldn't move. So yeah, it's not moving. So if I go back to active to 1, now it moves. So a little basic stuff there. All right. What I'd like to do is create a base here on the bottom of this structure and tell it to be inactive while the rest is active. It creates a foundation. It's very manageable. So if we move this over here, what I'm going to do is make a box, because what I want to do is create a platform down here with an attribute of 0 and transfer that to the structure. So if I've got a box, let's make this thing, 20, 20, 20. How big is that? Let's do 100. 100? Why isn't this updating? Oh, it's a stupid viewport. Let me, let's just do another viewport. Let's get rid of that. Scene view. This is what happens. Okay, hit D. I'm going to go back to dark. Okay. All right, here we are. Here we are. Here we are. Let's see if this works now. Let's put this to like 5. No, it's still doing that. I might have to restart Houdini. Okay, I'll be right back, guys. All right, I'm back. I think it should work. So let's go back into system. Select my box. Yeah. Yeah, okay. That happens. You know, just restart. It's all good. Okay, so I got a box. I'm going to throw on a scatter. So this scatter is all I'm going to do. I just need some points on this box. And then I need to put another attribute wrangle. Well, actually, I just delete this. Let's copy and paste this here, connect it. So I'm applying the active attribute of 1 to the structure. And now I'm going to apply the active attribute to the points of 0. So now I've got points on active on these points and active on the structure. So I want to transfer the 0 attribute based on a fall off to the closest geometry. So in order to do that, let's throw a well, let's separate this real quick. Put a null. It's always good to do that. Connect that. Move this up. Now attribute transfer. Awesome operator. Let's do, I want to transfer from, which is the right input, from the scatter points to the geometry. So if I select this now, I can just uncheck this. I need to transfer the active on the points. Now I get these nice little distance threshold and blend values here. All right, this is when we need to pull up our geometry spreadsheet. Let's select this. Let's get rid of that. And where's our actives? Right here. Okay, so you can see that we have 1s and 0s. If I put this to 0, the fall off and threshold, they're all 1. So if we start to move this up, now I can start to see some 0s. Now I would like to visualize this, because it's better to see things. All right, so in order to do that, let's do this. We need to unpack it, since these are packed. We need to transfer active back down to the unpacked level. So we got active and, yep, active. And let's throw out a color. Let's make it ramp from attribute and change this color to red or blue. Let's do blue. And what's the attribute? Well, active. There you go. And if let me change this to light. Okay, cool. So you can see everything that's active is blue and everything that is not active is 0. If you go up here, select the attribute transfer, start to adjust the value. You can see it update here with the blend. So all I need is the very base. So I don't want to go too far up. So maybe just like that. That's good. That's all I need. I need that as a foundation. Cool. So if I just take the input and switch it to the attribute transfer, save it, go back into the dot network. Since everything is active, I push play, it doesn't move. So that is what we want. So once we have an object that flies in and hits this, it's going to react just how I want it. It's going to keep the foundation. It's going to keep the top part. All right, let's throw in a collision object here. Let's move this over, get some room. All right, so in this video, I've got this like giant butter stick. I called it. That's just chucking in there. So I'll just do something similar, like a sphere or a block. I like these shapes. I don't know. They create a little bit more of an interesting result at the end. But let's just throw another box in there. Okay, so this is going to be. This will be the collision. And let's throw a transform. And let's scale this up. Oh, let's uniform scale. Scale this up out here. I need to visualize the structure, so I'll put the pink so it ghosts it. All right, here's the transform. I'm going to go to this guy here. Move it over. Let's give it some rotation. Let's throw it right there. All right, let's adjust the scale a bit. I'm just going to mess with this. Okay. All right, that's cool. Very simple, nothing crazy, but I need to apply some velocity to this guy so it can get inputted into the packed primitive object in the DOPS. So attribute wrangle. Let's throw down, apply some velocity. Okay, velocity. Let's just give it some velocity and call out the velocity. And then define it. So v for vector. Velocity is a vector. At v, it's calling out the velocity. Let's do, what is it? Z. It's got to be z. So we can see our gimbal down here. We need a negative z value. So dot z equals, let's do 1,000. Semicolon. All right, so you can see down here we applied 1,000 value of 1,000 to their z. So let's check and see if it works. So display point trails, this little button here. Cool. All right, that works. Now the blue, since it's pointed this way, kind of makes it seem like it's going to be traveling from to the left, but it's actually, you know, think of it as like a blur, motion blur. It's actually the trails, so it's actually going to the right. So let's reverse that. We could just go in here, times -1. There you go. All right. Now let's see what this looks like. But first, before we do that, we need to assemble this, because to bring it into the DOPS as a packed primitive, it needs to be packed. So just like that, create packed geometry, and we need to transfer the velocity. Remember that, don't forget that. And I just like to be consistent, so name this like a collision object. Save it. All right, now let's just throw out a null and name this out underscore collision object. COLOBJ. All right. And just for consistency, I'm going to name this out source. Okay, cool. Let's go into DOPS. Okay. Now, normally, if you have an animated like a collision object, you'd create a static object and use deforming geometry, blah blah blah. But this is what's going to happen is the dynamics will take over, and it will first see the initial velocity and evaluate in the first frame, and the dynamics will take over after that. So we just need another packed object. Before that, let's just rename this to, this is going to be source. And another RBD packed object here, and name this collision object. And we need to merge this together here. So 1, 2, 3. All right. Select this SOP path. So we could just point it to out collision object. Nice and organized. Now if we hit play, that just drops because we need to select inherit velocity from point velocity. Boom. There we go. We could turn that off. So we hit play. There we go. Now 1,000, that's really fast. And just start to let's start to manage this stuff a little bit better. Okay, so name this to velocity. And this is active. Just whatever. Active on. No, I'm sorry. This is the wrong one. This is active off. And this one's velocity. All right. Let's turn this down to about... Let's just do 100. See what that does. It's still a little weak. We'll set up some controls, some nice, manageable, intuitive controls later on, but just for now, let's get a nice value in here. So it'd be like 380. That sounds good. That's still pretty fast. Let's do 235. That sounds good. Okay, that's good enough. All right, so you can see it's behaving pretty well. Let's go back into constraints, show the network. We can see how it behaves. And real quick before we move on to the next step, I want to define some material properties. So you go to your you select your packed object, go to your physical tab. You got bullet data, physical. Density, this is probably going to be, this is pretty important to define before you get into really nailing down the constraint values and dynamics of this thing. So it computes it by size, sort of, but you really have to define it here. So the box would be, let's just do 100. Go to the source object. This would be, let's say, 500. Let's see how this looks now. It's still a little frail. But yeah, I think that's fine for now. We can get into start to building the stronger glue. Actually, let's just do that now. I'm going to set this to 7 on the glue. Let's see how that looks. That's a little bit better. All right. Oh yeah, one more thing. Let's go back up to the source. Bullet data. This is a little interesting. So this convex hull. Let's go show guide geometry. If I turn that off, that looks pretty good. This is always good to check and double check to see how this is doing. But I always like to check create convex hull per set of selected primitives. There you go. That's more accurate. Okay. Display geometry. Turn that off. Hit play. Cool. All right. So the integrity of this structure is going to depend on the next set of constraint networks we build, and the main one being the special one that creates a nice bending detection. So yeah, this is we've got it all set up. Let's just go over the network again. have our basic glue constraints we set up. We've defined active. We've defined the foundation of this. All right, here's the foundation of it. Everything we've created a visual aid for ourselves. Collision object has velocity, and now we've got everything set to build out more constraints around here and add more cool shit. So, all right, that wraps it up for this one. Step 3, we'll get into the cool constraints and cool behavior. So, all right, I'll see you guys later.